Hey everyone, in this video I'll explain the most common method for measuring acidity called pH. Before we look at pH, let's review some information about the H+ and OH- concentrations. These two values can also tell you if a solution is acidic or basic. To do that, you'd have to know both the H+ and the OH- concentration and then simply look to see whichever is larger. If the H+ is larger, it's an acid. If the OH- is larger, it's a base. So we could take an unknown solution like this one here that has an OH- concentration of 1.2 times 10 to the minus 3, solve for the H+ concentration and figure out if it's an acid or base. The first step, of course, is doing the math. To solve for that H+ concentration, we'll use this formula right here. Simply plug in the OH- concentration, solve for the H+ by dividing both sides by the 1.2 times 10 to the minus 3, and you'll find that the H+ concentration is 8.3 times 10 to the minus 12. Comparing the sizes of my two concentrations, I can see there's way more OH-, which now answers the question, and I know that this solution is basic. Now with pH, we have a better, faster way to do pretty much the exact same thing. pH is a scale that is used to quickly identify a solution as acidic or basic. Here's a pretty cool visual of the pH scale and some common household solutions and where they would fall on the scale, like lemon juice at a pH of 2, your blood at a pH of 8, or hand soap at a pH of 12. Here are some important details about the pH scale. First of all, it goes from 0 to 14, with low numbers 0 to 7 indicating you've got an acidic solution, and high numbers 7 to 14 indicating a basic solution. The symbol for pH is actually an abbreviation that stands for power of hydrogen. We'll understand that more when we look at the calculation behind pH. And lastly, pH is a special type of scale known as a logarithmic scale. Without getting too deep into the math behind what that means, it essentially tells us that whenever you jump from one number to the next, so imagine going from 6 to 5, even though it feels like those two pH values are relatively similar in acidity, the pH of 5 is 10 times more acidic than the pH of 6, pH of 4 is 10 times more acidic than a pH of 5. And that trend continues, jumping from one number to the next, and that's what it means to be a logarithmic scale. These important details make up our key ideas for the video. Make sure you've taken some time to write them down. So these details are helpful for using pH, but what they don't explain is what it really is. Where do these numbers come from and why do we need them? I like to think about it this way. Right now we have two methods for identifying a solution as acidic or basic. Let's put those two methods side by side with these two solutions. One way that you could determine if they're acids or bases is by comparing the H+ to the OH- concentration and picking which one is bigger. The second way you have is by simply stating the pH of the solution. Both of these two methods do exactly the same thing, but ask yourself, which one would you prefer to do? Which one is easier to do? To use this first method, you have to go through a whole lot of work. You might actually have to do some math to solve for one of the values if you've only got one of them to begin with. Once you've got both numbers, you still have to tell which one is bigger and then apply these rules to see if it's actually an acid or a base. To use the pH, however, all you have to do is look at the number, in this case 11.1, see that it's higher than 7, and you automatically know the solution is basic. The point is, both of these two methods give you the exact same information at the end, but using the pH is way simpler, way faster when it comes to telling if a solution is acidic or basic. Let's close the video by looking at how to calculate a pH value for yourself. pHs are calculated directly from the H+ concentration in a solution. So here's an unknown solution with an H+ concentration of 3.6 times 10 to the minus 5. The formula for calculating pH is taking the negative log of the H+ concentration you are given. Now don't panic if you don't know what a log is. You can do the math without actually understanding what you're doing simply by pushing the right buttons on your calculator. So the first step in using this formula, like it would be with any formula, is to simply plug in what you know. Luckily the pH formula is really simple. It only has one thing to plug in, the H+ concentration, and in this case that was given to me as 3.6 times 10 to the minus 5, so I can imagine plugging that in for the H+. Now let's finish it off by going to a calculator to see how we take the negative log of this number. I'm going to show you what buttons to push on this calculator. If you've got a different one, chances are pretty good that it also has a log button. You've just got to take some time and find it. But the series of buttons we're going to push here are probably pretty similar to the buttons you'll push on most scientific calculators. So let's start by entering the negative part of the formula by simply pushing the negative button on the calculator. Next thing I have to enter is the log part of the formula by simply pushing the log button on your calculator. Next, you simply enter the number you want to take the negative log of, in this case 3.6 times 10 to the minus 5. So I'll push 3.6 instead of times 10 caret. I'm going to use my EE button, second EE minus 5. You might have to also close the parenthesis to take the negative log of that number, so we'll do that as well. If you've entered it properly, it should look something like this. The final step, of course, is to actually get an answer by clicking the enter or equals button. And when we do that, the calculator should give you an answer somewhere around 4.44. Now I know that my solution is acidic. So this pH formula is really useful and is another one of our key ideas. Make sure you take a moment and write it down. Now the pH formula is pretty simple, but it does introduce some things that might be new to you. So I highly recommend you find whatever calculator you use, pause the video and see if you can do this on your own. Here's a can of tomato juice. It has an H+ concentration and 2.7 times 10 to the minus 4. See if you can calculate the correct pH value for this tomato juice. If you're using this calculator or something similar, here's the buttons you should be pushing. First, negative and log. Then enter the number of 2.7 times 10 to the minus 4, close the parentheses and hit enter. It should look like this before you hit enter and actually take the negative log of the number. The correct final answer, if you did it properly, is 3.57. My tomato juice appears to be acidic. That concludes this video on pH. Here's a brief summary.